Triton is an exceptionally unusual, although often forgotten moon. It has so many unique characteristics, it makes it one of the most interesting objects in the solar system. But because it is the largest moon of Neptune, the planet furthest away from us, it also means that we have only visited it once. Very briefly, as Voyager 2 flew by all the way back in 1989, 30 years ago. Triton orbits clockwise around Neptune, as Neptune rotates counterclockwise. And Triton orbits at a 130-degree angle to the ecliptic of the planet. Although, it should be noted that its orbital eccentricity is close to zero. Its orbit is almost perfectly circular. All other large moons in the solar system are regular moons, orbiting the same direction as the rotation of their parent planet. What this heavily implies is that Triton did not form alongside Neptune, but it is in fact a captured object. Specifically, a captured dwarf planet. No wonder then that it is by far the biggest of Neptune's 14 moons, comprising 99.5% of the mass found in Neptune's orbit. Although Triton is a moon of Neptune, it could be said that it is the biggest and most massive Kuiper Belt object. Further evidence for this was found as New Horizons passed Pluto in 2015, suggesting Triton and Pluto share a near identical composition, which supports the theory that they share a common origin. I mentioned that Triton shares similar characteristics with Pluto. What exactly does that entail? Well, they both have a predominantly nitrogen ice surface with other ices mixed in, like water and carbon dioxide. It has quite a flat terrain. Its topography never varies by more than a kilometer. Although Voyager 2 did see ridges and troughs, plateaus, and ice plains. What you may find unusual though, is that it has very little in the way of craters. This implies its surface is very young and is constantly being renewed. Triton's atmosphere is thin, only 0.014 millibars, about the equivalent of 80 kilometers up on Earth, although, like Pluto, this density varies through seasonal changes. Since Voyager 2's observations, Triton's atmosphere has become denser as the surface has warmed, evaporating a little of the nitrogen ices on the surface. However, when Voyager 2 passed, Triton's atmosphere was still dense enough to support weather up to 8 kilometers above its surface. In this image, you can actually see clouds on Triton. And going back to the image of the plumes, you can see the deposits from the eruptions all end up facing the same direction, due to a prevailing wind in that region of the moon. Like Pluto, Triton's atmosphere is hazy, the cause of which is thought to be hydrocarbons in the atmosphere not yet broken down into tholins by UV light from the sun. The constant depositing of organic compounds through cryovolcanism, ices evaporating and freezing again through seasonal variations, and a weather-rich, active atmosphere makes Triton a very dynamic world, unlike most other moons in the solar system. It is more a dwarf planet than a moon, likely a sibling of the more famous Pluto in the Kuiper Belt. All of these factors combined make it one exceptionally unusual moon.
Orbiting Jupiter, the largest planet in the solar system, is a total of 80 known moons, all of which are fascinating in their own way. But arguably the most interesting of them all is one of the Galilean moons, the mysterious icy world named Europa. Crisscrossing Europa are vast cracks and discoloured streaks that combine to create a complex yet beautiful world. And when looked at even closer, many more strange features can be seen, such as Europa's mysterious freckles. But what are these strange freckle-like features, and what is causing the chaotic fractures that weave across Europa's frozen landscape? A total of 6 spacecraft have visited Europa up close, photographing the stunning moon as they passed by. but most of what we know about it comes from several years of observations made by NASA's Galileo spacecraft. A total of 12 close flybys of the icy moon. Despite its fractured and discoloured appearance, scientists discovered that it is the smoothest solid object in the solar system. Its highest peaks, for example, are only a few hundred meters tall, and large craters are rare. This smoothness means that the surface of Europa is fairly young, probably only tens of millions of years old rather than billions like most other moons. Somehow, the ice is being resurfaced on Europa and smoothed out faster than on many other worlds. The question of why that happens has not been definitively answered yet, but it probably has something to do with what's going on below Europa's mysterious surface. Take this image captured by the Galileo spacecraft, for example. Several strange spots or freckle-like features can clearly be seen scattered across its frozen landscape. The spots visible in this image are about 6 miles across, which is about 10 kilometers across, and many are smooth domes. Some are jumbled pits, and some seem to have a reddish-brown hue. They are called lenticulae, which is the Latin term for freckles, and the similar size and shape of these spots suggest that warmer ice is rising up through the colder ice of the outer crust of Europa, much like magma chambers in Earth's crust. This process would be similar to that of a lava lamp, for example. The smooth, dark spots may have formed when the warmer, rising ice erupted through the surface, while the jumbled up, rough lenticulae could be formed from small, cracked fragments of the crust embedded in the dark ice from below, appearing like icebergs in a frozen sea. Whereas if you look closely, the tops of the dome-like structures are very similar to the surface around them, suggesting that they were formed when the crust was pushed up but did not rupture like the darker spots in this area. Recent studies have found that these mysterious features may sit above vast lakes of liquid water that are entirely encased within the icy outer shell of Europa. This cracked outer shell is estimated to be made mostly of water ice, frozen as hard as granite, and is approximately 15 miles thick, which is about 25 kilometers thick. But where is this liquid water coming from? Well, it turns out that these lakes may not be the only bodies of water Europa is concealing, because below this icy shell, scientists have also found evidence of a global salty ocean. Europa's most striking feature is its dark, crisscrossing, linear fractures and ridges that stretch around the moon called lineae, which is Latin for lines. What caused these cracks is still a mystery, but they are likely weak points within its ice crust, which are being affected by Jupiter's immense gravity, along with the other Galilean moons. The icy moon gets stretched and released by the tug of Jupiter's powerful grasp in an endless cycle as Europa orbits the giant planet. This squeezing in and out is a process called tidal flexing, which may be causing these colossal fractures and ridges. The tidal flexing may also be creating enough heat inside Europa to maintain a global liquid ocean beneath its frozen surface. As you can see, the cracks aren't deep gaping voids, but instead appear to be filled in with dark material, suggesting that some of them may have also been caused, at least partly, by the ocean below. Scientists found that the patterns of some of the longest lineae did not fit predicted patterns of fractures that should be created by tidal flexing as Europa orbits Jupiter. They determined that the patterns would fit very well, however, if Europa's surface could move independently and was not locked to the rest of the interior, as would be the case if a layer of liquid existed between the crust and the moon's rocky mantle, for example. Another piece of evidence for Europa's secret ocean is measurements that Galileo made during its multiple flybys. Galileo detected that Jupiter's powerful magnetic field was being disrupted in the space around Europa, strongly implying that a special type of magnetic field was being created deep within the icy moon. And scientists think that the most likely cause for this mysterious magnetic signature is a global salty ocean. And what's fascinating is that we may have already seen the water from this secret ocean escaping into space. Astronomers using the Hubble Space Telescope have imaged what could be water vapor plumes erupting off the surface of the icy moon, as seen in this incredible image. If this is water plumes, then it increases the possibility that future missions to Europa may be able to sample its ocean without having to drill through the hard ice. So what are these mysterious, freckle-like features found on Europa's surface? Well, they are strong evidence that below its frozen crust, large pockets of water exist. And along with even more evidence, those pockets may be sitting above a concealed, global, salty ocean that contains possibly 2 to 3 times as much water as all the water on Earth. And what's really exciting about this potential discovery is that scientists think that Europa's subsurface ocean could be the best place to look for life beyond Earth. Because of Jupiter and the other Galilean moons tugging on Europa, its seafloor could be heated by constant tidal flexing, driving hydrothermal activity similar to the undersea volcanoes in Earth's oceans, for example. It is possible that with the correct ingredients for the chemistry of life under the ice of Europa, it could be habitable. With all this tantalizing evidence, Europa is one of the most exciting places in the solar system to explore, and we have 2 future missions to look forward to. The first is NASA's Europa Clipper spacecraft, which will perform dozens of close flybys, investigating whether the icy moon could have the right conditions suitable for life. The spacecraft will pass the moon as low as just 16 miles, which is just 26 kilometers above the surface, soaring over different locations during each flyby. Estimated to launch in October 2024, we haven't got long to wait for this mission to get started, but we do have to wait a while until we start seeing the results, because Europa Clipper won't arrive at Jupiter until April 2030. The second mission we can look forward to is ESA's JUICE spacecraft, or Jupiter's Icy Moon Explorer. JUICE is designed to observe Jupiter and 3 of its large moons, Ganymede, Callisto, and Europa. Incredibly, ESA plans to enter JUICE into an orbit around Ganymede towards the end of the mission, becoming the first spacecraft to orbit a moon other than the moon of Earth. The spacecraft will launch in April 2023 and arrive at Jupiter in July 2031, so again, we have a few years to wait yet. But both missions will bring brand new views of this mysterious moon, and possibly confirm that it does have a global, salty ocean beneath its ice that could support life as we know it. The early 2030s is going to be an exciting time for space exploration.
The moon appears to be a sterile, gray, unchanging world. But while the moon has remained largely unchanged during human history, our own understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin, a feature that's as wide as the distance from New York City to Cincinnati. The interiors of some craters in the moon's polar regions, like Shackleton, haven't seen sunlight in over 2 billion years. However, new measurements have created our best yet maps of these types of craters, allowing us to see deep into the shadows of this surprisingly young-looking impact crater in the south that's more than twice as deep as the Grand Canyon. Some impacts are invisible for other reasons. Although the ancient South Pole Aitken Basin is difficult to see from orbit because it is so large, new LRO topography maps reveal the largest impact basin in the Earth-Moon system, measuring several kilometers in depth and around 2,500 kilometers in diameter. Only the Hellas Basin on Mars rivals it in size. One of the youngest large-scale impacts on the Moon is the Tycho crater. This fresh crater may have formed only 108 million years ago, when dinosaurs roamed the Earth. We now also have an extreme close-up view of the crater's central peak, revealing a mountain with sharp edges, building-sized rocks, and a central boulder about the size of a baseball stadium. The Aristarchus Plateau is another recent lunar formation that has long interested scientists and astronomers. The crater itself formed in the same era as the Tycho crater, and what appear to be snaking river valleys were actually carved by ancient lava flows. Next, we arrive at Mare Serenitatis on the near side of the Moon. In December of 1972, the crew of Apollo 17 landed in the Taurus Littrow Valley, marking the last time humans have visited the surface of the Moon. With images from LRO's narrow-angle camera, we can clearly see the evidence of that visit. In this image, you can easily see the base of the lunar lander, along with the lunar rover, parked far from the blastoff zone. You can also clearly see the astronaut trails and the wheel tracks left on the lunar surface. We now head to the far side of the Moon, which cannot be seen from Earth. Our first stop is the Compton-Belkovich region, which shows evidence for young volcanic activity in the far side highlands. This feature is unique not only because it is isolated from other volcanoes in the area, but also because it is located nowhere near the Maria, where volcanoes are usually found. Also, on the far side, we find the Jackson crater, which, like the Tycho crater on the near side, has an extensive and complex ray system. In fact, this crater is often considered to be like a twin to Tycho. Finally, the Tsiolkovsky crater stands out as an excellent example of a far side crater filled with a sea of ancient lava, known as a mare. It is particularly interesting to scientists and other observers because of its isolation from other similar craters, as well as its beautiful central peak. As we continue to study the Moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the Moon and better understand the history of our solar system.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the Moon and returning him safely to the Earth.
Apollo 11, 30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Oh boy. Oh boy, it looks good, Wally.
Somebody must be leaving town.
Building shaking. Getting that buffeting we've become used to. What a moment. Man on the way to the moon.
Okay, let's go there, Capcom on the hot fire. Okay, all flight controllers going around the horn, gonna go for undocking. Okay, retro, go. Fido, go. Guide, go. Control, go. Telcom, go. Jinsei, go. Ecom, go. Surgeon, go. Capcom, we're go for undocking.
Armstrong, Aldrin, and Collins arrived at the Moon on Saturday, July 19th. The next day, Sunday, July 20th, was landing day. Think about it as a controlled fall out of lunar orbit. The problem is, in this controlled fall out of orbit, you only have enough fuel for one try.
Capcom, we're go for landing. Altitude 4200.
Houston, you're a go for landing, over.
So now we're critical fuel state.
And that's why the 60-second call was given, and then the 30-second call.
Okay, engine stop. ATA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 413 is in.
We copy you down, Eagle.
Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing it.
I'm going to step off the limb. That's one small step for man, one giant leap for mankind. Oh, that looks beautiful from here, Neil. It has a stark beauty all its own.
20 minutes later, Aldrin climbed down the ladder and joined his partner.
There, you got it? That's a good step. Yeah. About a 3-footer. Beautiful.
Then the first man on the moon read a plaque attached to a leg of the Eagle.
Underneath it says, "Dear men from the planet Earth, first set foot upon the moon, July 1969, AD. It came in peace for all mankind."
The two planted the United States flag on the surface. President Richard Nixon called to congratulate the astronauts. Armstrong and Aldrin went back to work collecting samples of moon rocks and dust. 2.5 hours later, at 17 hours and 54 minutes UTC, they lifted off in Eagle's ascent stage to rejoin Collins aboard Columbia in lunar orbit.
Port stage pushed. Engine arm is out. Okay, I'm going to get the pro. 99, proceeded, 3, 2, 1, ignition. Right away, Houston. Regs are good. Ag shot. Pitch over. That's good. 90, okay, off, 50.
Guidance reports both navigation systems on Eagle are looking good.
Columbia fired out of lunar orbit to begin its 3-day fall back to Earth, where the recovery fleet was waiting for its splashdown in the Pacific.
Apollo 11, Houston, with a little recovery.
Never to return.
Velocity 33,000 feet per second. 35,000 feet per second now. 36,000 feet per second. We're at entry time. There's blackout.
Houston to Orion, standing by. Over. Strokes. Apollo 11, this is Hornet, over. Apollo 1, this is Apollo 11, reading you loud and clear. Our position 1330, 6915. 11 Hornet, copy, 1330, 1675. Any further data, over? 330, 169er, 1.
Io is the innermost and third largest of the 4 Galilean moons of the planet Jupiter. Slightly larger than Earth's moon, Io is the fourth largest moon in the solar system, has the highest density of any moon, the strongest surface gravity of any moon, and the lowest amount of water, by atomic ratio, of any known astronomical object in the solar system. It was discovered in 1610 by Galileo Galilei and was named after the mythological character Io, a priestess of Hera who became one of Zeus's lovers. With over 400 active volcanoes, Io is the most geologically active object in the solar system. This extreme geologic activity is the result of tidal heating from friction generated within Io's interior as it is pulled between Jupiter and the other Galilean moons, Europa, Ganymede and Callisto. Io's surface is also dotted with more than 100 mountains that have been uplifted by extensive compression at the base of Io's silicate crust. Several volcanoes produce plumes of sulfur and sulfur dioxide that climb as high as 500 kilometers 300 miles above the surface. Io's surface is also dotted with more than 100 mountains that have been uplifted by extensive compression at the base of Io's silicate crust.
Callisto, discovered in 1610 by Galileo. It is the second largest moon of Jupiter and the third largest moon in the solar system. Callisto is 4,800 kilometers in diameter, and it is just a bit smaller than the planet Mercury, but it as well as 1/3 the mass of Mercury. Callisto has a surface area of 73 million square kilometers, which is similar to the surface area of Asia and Africa combined, so it is quite a big place. This large moon has one of the oldest surfaces in the solar system because there was no geologic activity going on to change it, which is why it is as well one of the most heavily cratered objects in the solar system, close to saturation. So then, what would standing on this ancient surface of Callisto be like? First, the temperatures average -139 Celsius, which is not that bad for an object 700 million kilometers away from the sun, but it is still quite cold. Now, there are no mountains on Callisto, but there are places that contain gigantic ice spikes created by ejecta. These average around 100 meters in height, and there are a lot of them. Getting around these spikes would be like walking through a maze. Looking up, the mood would be much less exhausting than on the Earth. Taking a look in a distance, you would see a fairly harsh and deformed landscape. It would be icy and metallic. There would be craters within craters. And since there was no resurfacing on Callisto going on, if you could bring a microscope and take a look at the rocks, you would see many more miniature craters inside craters, all down to the microscopic level. Those were created by many microscopic rocks and particles hitting the surface, and the craters stay there because of near vacuum and no activity. Generally, the color of the surface would vary a bit, from gray to a very bright color, which means that while being in these bright spots, it would be harder to see since it is very reflective. It also could teach us a lot about the past of the solar system, since there was no activity going on it since the formation. Interestingly, there has been some research
on Callisto, moon of Jupiter.
Triton is the largest moon of Saturn, the second largest in the solar system and larger than any of the dwarf planets of the solar system. It is the only moon known to have a dense atmosphere, and is the only known object in space other than Earth on which clear evidence of stable bodies of surface liquid has been found. Triton is one of the 7 gravitationally rounded moons in orbit around Saturn, and the second most distant from Saturn of those 7. Frequently described as a planet-like moon, Triton is 50% larger, in diameter, than Earth's moon and 80% more massive. Triton is just one of Saturn's 83 known moons. On January 14, 2005, the Huygens probe made a historic journey of approximately 2.5 hours through Triton's hazy atmosphere to the surface. The instruments on board Huygens were designed to find out what aerosols, and therefore chemicals, were present in the atmosphere. Previous remote studies of Triton told scientists that its atmosphere was made out of nitrogen and methane, but the Huygens probe was able to directly investigate what different gases were present. In addition, one instrument made measurements to find out if clouds and lightning occurred. A series of parachutes opened to slow the probe down. At around 160 kilometers above the surface, the probe's scientific instruments were exposed to Titan's atmosphere and started to transmit data to the Cassini orbiter. The entire mission was designed to take place during the descent through the atmosphere. It was hoped that scientists would get a few minutes of data once the probe reached the surface. However, it was not known if the probe would survive its impact, and scientists did not know what kind of terrain it would land on. During the journey through the atmosphere, Huygens instruments also investigated the surface of this moon. A camera took images and collected light to determine what elements, chemicals, or minerals were present on the surface. Another instrument studied the Titan landscape to distinguish, before impact, whether the surface was liquid or solid. As Huygens traveled through Titan's alien atmosphere, it was carried by the wind. Computer modeling of the atmosphere, based on the winds, revealed that it is like a giant conveyor belt circulating the wind from north to south and south to north. Measurements of the hazy, thick atmosphere confirmed that complex organic compounds, the building blocks of the amino acids necessary for life, were present in both gas and solid phases. Until the Cassini-Huygens mission, little was known about the surface of Titan. Despite atmospheric haze, the cameras on board the Huygens probe were able to take clear images of Titan's surface. The first images of the surface showed a world that resembled the Earth in many ways, with evidence that a liquid, possibly methane, had flowed on the surface, causing erosion. At the landing site of the probe, the surface was found to have the consistency of loose wet sand that was mostly made up of dirty water ice pebbles. The surface material detected gases that had not been found higher up in the Titan atmosphere, including carbon dioxide. The Huygens probe also measured the weather conditions at the surface, detecting light winds, a temperature of -170 degrees Celsius, and an atmospheric pressure slightly higher than Earth's. Traveling at a speed of just 18 kilometers per hour, Huygens made a gentle landing on the surface of this alien moon. Huygens was the first probe to land on a body in the outer solar system and the furthest from Earth. On impact with the Titan surface, an accelerometer measured how quickly the probe stopped moving. A suite of sensors then started to find out what it was like at the surface, measuring properties such as the temperature and how quickly sound and light waves traveled.
Jupiter's icy moon Ganymede is the largest moon in our solar system, even bigger than the planet Mercury, and the dwarf planet Pluto. There's strong evidence that Ganymede has an underground saltwater ocean that may hold more water than all the water on Earth's surface. It might even have ice and oceans stacked up in several layers like a club sandwich. Ganymede is the only moon known to have its own magnetic field, something typically found on planets like Earth. The magnetic field causes auroras, or bright ribbons of glowing gas, that circle the moon's poles. There is evidence Ganymede has a tenuous oxygen atmosphere. Images taken by NASA's Juno spacecraft on June 7, 2021, provided a fresh look at features on Ganymede's surface, including craters, clearly distinct dark and bright terrain, and long structural features possibly linked to tectonic faults. Deep inside Ganymede, there's a metallic iron core that generates the moon's magnetic field. A shell of rock surrounds the core, and another icy shell surrounds the rock. Ganymede has a radius of 1,635 miles, 2,631 kilometers, and is about 665,000 miles, 1.07 million kilometers, from Jupiter, which orbits about 484 million miles, 778 million kilometers, from the Sun. Jupiter is 5.2 astronomical units away from the Sun. 1 astronomical unit, abbreviated as AU, is the distance from the Sun to Earth. From this distance, it takes sunlight 43 minutes to travel from the Sun to the Jovian system. The large moon completes an orbit around Jupiter about every 7 Earth days, 7.155. Ganymede orbits the Sun along with Jupiter and its other satellites every 12 Earth years. Ganymede was discovered by Italian astronomer Galileo Galilei on January 7, 1610. The discovery, along with his discovery of 3 other large moons around Jupiter, was the first time a moon was discovered orbiting a planet other than Earth. The discovery eventually led to the understanding that planets in our solar system orbit the Sun, instead of our solar system revolving around Earth. Jupiter now has 53 named moons and 26 provisional moons awaiting confirmation of discovery.